Hello, AE7TO here, and I'm going to be demonstrating the use of PCALE software for the purposes of band selection on point-to-point HF links. On your screen right now, you see a VOACAP prediction for a path from just south of Salem, Oregon to up near Seattle, Tacoma, Washington. Let's say for the sake of argument that we want to be able to use single sideband voice communications between those two sites, and that because we're using compromised antennas and portable power, we don't expect to have more than about 50 watts, if that, in terms of effective radiated power. When you run the prediction for today's conditions, you get a chart that's something like this. Much of the time, the prediction is that 80 meter would be your best bet. But you can see there are times when 60 meters or 5 megahertz band is actually going to be a better bet than 80 meters. And of course, these are just software predictions. Your mileage may vary in real life. And you also have the challenge of coordinating band changes at each end of the link. Assuming there's a regional disaster, that means you can't use cell phones, internet, or landlines in order to coordinate when to switch bands and what mode to use on each band. One of the challenges is deciding what band to switch to, what mode to switch to, and to somehow have that happen at both ends of the link so you can maintain communications. So it's sort of a catch-22. You can't coordinate the change when you can't communicate in the first place. So I'll minimize this and show you two stations. They're actually both right here, but I've got a dummy load on one end where the transmitter is located here, and I've got a receiver set up here a short distance away with a small vertical antenna. They're both running PCALE software, and I'll describe details of the configurations in a moment. But for now, I'll just say that they're both set up for the same channel group, everything from 10 meters to 80 meters to include 5 megahertz band, and they're both configured pretty much identically, except the station on the left has a transceiver connected to it, and the station on the right has a software-defined receiver. Specifically, it's a SoftRock SDR hooked up to the Toughbook on the right. So what I'm going to do is I'm going to turn scanning on the right-hand software-defined receiver, and it's going to start hopping through all the frequencies in my channel group. I've got it set up for a 1 channel per second hop rate, which should work for most radios. And you can see the HD SDR frequency indicator here changing again at about a 1 channel per second rate. And on the left, we've got a Yaesu FT857D radio hooked up to the PCALE software, and I don't have a fast auto tuner on that radio right now. Actually, what I have on that radio right now is a dummy load. But in real life, in a portable setup, you may not have a fast auto tuner. You may have to manually adjust your antenna coupler each time you change bands. So you may not want to put this transmitter in full automatic scanning mode in some situations, especially with a portable setup. So if you have PCALE set up the way it's designed to be used, both ends would be hopping, and you could simply turn it on, and periodically the transmitter would sound on each frequency in the channel group, and the receiver would also scan through every channel in the channel group, and periodically the receivers in your net would receive soundings from all the transmitters in the net, and you'd gradually build a list of stations in your net, and then when you're ready to actually talk, you'd simply select the destination from the call list that's been built based on the soundings, and then you'd start talking, either sending messages or phone mode, take your pick. The challenge with that is that in order for these radios to hop at the rate of 1 channel per second, from 10 meters to 80 meter bands, you have to have either a multiband antenna that has relatively low SWR across all those bands, which is another way of saying a dummy load, or you have to have an auto tuner that's capable of rapidly adjusting to each band when you do these changes. So that may make a lot of folks reluctant to use PC ALE software, especially in a portable setup the way it's intended to be used. So what I'm going to demonstrate here is a way that you can use rapid hopping or rapid scanning on the part of software-defined receivers, and you can use manual band tuning followed by manual sounding in order to test each of the bands. And then once you figure out which bands are suitable for communications, then you can send out a message from the net control station to the other stations, letting them know what band you all need to converge on. So again, right now I've got my receiver scanning 1 channel per second. I'm going to go ahead and take my best guess at what band I want to use, and I'm going to go ahead and send a sounding on it. I'm going to start with the 80 meter band. So I will press manual sounding, and there the station is transmitting. We haven't yet switched to that band here, but once this station gets to that band, you should see the signal come in, the sounding come in. 10 meters, there it is, 80 meters right there. And it wasn't received. Now, I should have mentioned one of the reasons that it wasn't received is because this receiver has a bandpass filter on the input to that software-defined receiver. That SoftRock has a bandpass filter on the input that pretty much limits it to the 20, 30, and 40 meter bands. So I just tried to send it a signal on the 80 meter band, and not surprisingly it wasn't received. So let me go ahead and switch to a more acceptable band. You can see as I press this advance button right here, the actual frequency that the radio is tuned to is displayed at the bottom. Okay, there's the 60 meter band. And there I've got the 40 meter band, 7.102 megahertz. So I'm going to try sounding on that band. Here in the heard list, I see that just now I received a sounding from AE7TO, that's me, and it was on 7.102 megahertz. So let me try another band. I'm going to switch up to the 30 meter band. Okay, there we go, 10.145 megahertz. I'm going to go ahead and sound on that band, manual sounding. And again, I wait for the receiver to go around to that channel. And now I have the sounding on both the 40 meter and the 30 meter band. And you have some quality indicators over here. It looks like the signal noise ratio on the 40 meter band is a little bit better. So let's do one more. I will try the 20 meter band, start a manual sounding, and is our best bet. So let me go ahead and switch to the 15 meter band and try sounding there. I will probably find that it won't work. not enough signal was received for it to show up in my sounding list here. So what you've seen is I've been able to manually control my transmitter. And because I'm not trying to hop at the 1 second per or 1 channel per second rate, I've got lots of time to manually match the antenna, the portable antenna, to my transmitter, and then I can transmit at my leisure with confidence that this rapidly hopping receiver will hear my signal once it gets around to it. So in the kind of scenario I'm talking about, each station would set up an SDR, perhaps something as modest as a Raspberry Pi, hooked to probably a SDR Play or some other software-defined radio, and then it would hop through the channel set using cat control of the SDR, and it could do it at, in this case, it's 1 hop per second. You could configure it for 2 or even more hops per second. And then the other stations would, once they've got their equipment set up, they would go ahead and do a manual sound on each of the frequencies that seem like they're likely to work. And then when all the stations have seen the soundings from all the other stations, the net control station would probably be the one to decide what band you're all going to converge on. And at that point, they would want to send a message. So I'll go ahead and do that right now. I will send a call individual to, let's see, I don't have a call sign in here I want to use, so let's create one. And I'm going to use a tactical call sign. And now I can go ahead and call that station. There's the one I just added. And I want to go ahead and click the This Was option, which means I'm not going to wait for an acknowledgement. And I'm going to tell everybody on the net that I want to go 40 meter, and I'm going to tell them to use Thor 11. I go ahead and click OK, and now this station should start transmitting that message. I'm still hopping over here, and I got lucky and pretty quickly and there's the message. In this case, it was actually received on the 21 meter band. Even though that wasn't the band I'd intended to use, I probably should have sent it on the 40 meter band. I would have had a better chance of success, but in this case it was actually received. So all the other SDRs in the network would have been able to see that message, and they would now know that they need to go to the 40 meter band and use Thor 11 mode in order to establish contact on the net. So that's the basic paradigm. You've got automatic scanning by a bunch of receivers, one at each station, and you've got manual sounding from each of the other stations. And the reason for manual sounding is it allows you to have lots of time to match your antenna to your transmitter before you press sounding. If you do happen to have a station that's capable of rapidly switching to a new band and immediately transmitting on that band, then by all means use the ALE software the way it's designed. You can put both transmitters and receivers in full auto mode. You don't need separate SDRs, and everything will work the way the designers intended with this software. But the scenario I'm talking about involves portable antennas, portable stations, and perhaps you're not well equipped for these rapid and automatic band changes. In that case, this is one way that you can first of all test the conditions on each of the bands, and then make a choice based on the soundings for each of those bands, and then somebody who's got the role of net control would send out a message to all the other stations announcing the desired band. And I'll go ahead and once again illustrate how to send that kind of message. I'm going to this time do it on the correct band. So I'm switching through the available bands until I get to the band that the soundings have shown that this band is the one we want to use, the 40 meter band. So I'm going to once again send a message to the tactical call sign for the group telling everybody to go to that band. This time I'll tell them Thor 22. I'm more optimistic now. Again, I want to use this was mode. And we should now once it's decoded, it'll show up in the list. This time it came in on the expected band, the 40 meter band, and once again the message is go to the 40 meter band, Thor 22. So that would be how you'd communicate the decision by net control based on these manual soundings as to what band you're going to want to use. I'll very briefly go over the settings that are used in this demo for anybody who wants to conduct some experiments along these lines. First of all, on the software-defined radio end, where I've got a receiver, you go into your mil standard options and you set your scan rate. I'm using 1 channel per second. Even older radios should be able to hop at that rate. Because I'm using HD SDR to control my software-defined radio, it uses a primitive Kenwood instruction set, a subset of the Kenwood instruction set. You have to tell it your port settings, which are a baud rate of 4800 and 81, so 8 bits, 1 stop bit, and no parity. And you have to give it your port number. Of course, the port number in HDSDR is set in your CAT settings. So let me move this up so you can see it a little better. HDSDR port settings are here. That's your port, COM4, which by the way, that's actually one end of a virtual null modem cable. The other end is COM5. So the radio is connected to COM4 of a virtual null modem cable, and the CAT control software is at COM5, which is the other end. Baud rate is currently set to 9600. We don't care about the push-to-talk activation. And this checkbox simply says that CAT control is activated. Some other important settings on the PC ALE software. You want to have link quality analysis so that you can judge the quality of the link. You don't need these options. You do want to display all soundings from other stations, and you do want to listen to all calls from other stations. For example, this call to the tactical call sign would not otherwise be displayed because it would have been addressed to another station. So to eavesdrop on messages to other stations, including tactical call signs, go ahead and check that block. This just frequency display means you display the current operating frequency at the bottom of the window here. Listen before transmitting. It doesn't matter on this end because this is a receiver only, but this will often inhibit transmitting on the other end, on the transmitter end. So in many cases you're not going to want to check that. This doesn't really matter for this SDR setup, but for some interface cables you need to turn on DTR in order to power the interface. You may want to use CAT for push to talk, or you may use RTS. It just depends on your settings on your transmitter end. Now on this end I'm going to turn off sounding. There's no sounding whatsoever. This is just a receiver, so I leave the default of no sound. And most importantly, this is the COM port number that is used for the SDR. The other important settings are here. You have to configure the sound card device. In this case, the HDSDR has its sound card output going into a virtual audio cable, and the other end of that virtual audio cable is the input to the PC ALE software. That's how the stuff heard by the SDR is picked up by the ALE software. And on the receiver end, the sound card levels don't matter that much. You can adjust the volume level as necessary to put the waterfall here at about mid-range. But other than that, that pretty much finishes the receiver end setup. When you want to stop scanning, you press the pause button. If you want to step through the frequencies one at a time, you use that button. And if you want to start automatic full speed scanning, you click that button right there. So that's the receive end. Briefly on the transmitter end, much of this is the same. The mill standard options are, once again, you want a matching scan rate at the transmitter end. We use one scan per second or one channel per second at the receiver end, so we're going to use the same rate at the transmitter end. You want to make those match because otherwise the timing is going to be off. You may have situations where by the time the receiver gets around to the frequency you're sounding on, you may stop transmitting. If you're, for example, hopping at 2 channels per second, it's going to assume everybody's receiving at 2 channels per second, and the timing just won't work out correctly. In this case, I'm using an FT857, so that's the radio type I need to configure. Port settings are to match whatever it is set up on the radio. Once again, you need link quality analysis. You do want to display sounds. You do want to listen to other calls. You do want to display frequency for convenience down at the bottom of the screen. And these are the options that work for my CAT setup. And in this end, it's COM6 that is my radio port. For sound card, once again, I have to set this to whatever device is connected to my radio. And in this case, I've turned my output device volume way down because I don't want to drive the radio into the dummy load at 100 watts. There's no need for that. But suffice it to say, in real life, you're going to set this slider to wherever you need to have about 30 to 50 watts of output power. If you go higher than that, you're going to start having intermodulation distortion on your output. You'll start splattering all over the place and have difficulty decoding at the other end. I think that pretty well summarizes the idea here. Again, the bottom line is you're trying to figure out how to coordinate band selections, and for that matter make band selections on point-to-point HF links. And in this case, we're using PC ALE software to scan at all of the stations, and also the same software to transmit soundings manually from each station. And once net control sees what bands work by scanning the successful soundings, they can send out a message to everybody on the net announcing the desired band. One last thing I should mention is that because we're talking about putting these SDRs co-located with transmitters, you're probably going to want to use a transmit receive switch or diode protection of some kind on the SDR input, so that when somebody keys the transmitter with an antenna just a few feet away, typically you don't want to blast the input of your SDR with that kind of signal. You may damage it. Okay, thanks for listening, and I'll provide some additional information in the text below the video.